Hello, grade 12s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabutiwa Sos Ugobela Wemets. And without any further ado, let's look at these questions that we have here. Okay, so we have question 5. It says a group of learners use the apparatus below to investigate one of the factors that affect the rate of decomposition of hydrogen peroxide, H2O2. The balanced equation for the reaction is 2H2O2 in aqueous form to give us 2H2O in liquid form, meant to say, plus oxygen gas. Then 5.1, as expected, define the rate of reaction in words. So we are going to say rate of reaction is what? So we are going to say rate of reaction is the change in the concentration of the products or reactants per unit time. Right. Okay. Then the learners conduct 2 experiments. The reaction conditions are summarized below. Experiment 1, we have 50 centimeter cube of a 1 mole dm cube of hydrogen peroxide solution, initially at 25 degrees Celsius and is heated to 40 degrees Celsius. In experiment 2, 50 centimeter cube of a 1 mole dm cube of hydrogen peroxide solution, to which a small amount of a substance Y, initially at 25 degrees Celsius, is heated to 40 degrees Celsius. So we don't know this substance Y, but then in most of the cases, it might be a catalyst that has been added. So let's find out. 5.2, how does the initial average kinetic energy of H2O2 molecules in experiment 1 compare with the initial average kinetic energy of H2O2 molecules in experiment 2? So the initial average kinetic energy. Okay, so remember, the average kinetic energy is directly proportional to temperature. So from grade 10, your kinetic molecular theory, KMT, says temperature is directly proportional to average kinetic energy of molecules. So since both experiments are done at 40 degrees Celsius, that means they would have the same average kinetic energy because the temperature is all the same or kept constant in both the experiments. So in 5.2, we would have to say equal to. There is no change in temperature, right? So our temperature directly proportional to kinetic energy. So since there is no change in temperature, there is no change in the average kinetic energy of the molecules. Okay, then 5.3 says the reaction in experiment 1 takes 15 seconds to run to completion. 15 seconds to run to completion, producing a total volume of oxygen of 28 centimeter cube. Calculate the average rate of reaction in centimeter cube per second from the start to completion of the reaction in experiment 1. Okay, so let's calculate that one. So it's basically just a straightforward question. We are just going to say rate of reaction is change in volume over change in time, right? And then obviously we are going to have final volume that was produced of the oxygen is 28. Then since oxygen is a product, we assume that there was no oxygen that was produced at the beginning of the reaction because we only had the hydrogen peroxide, which was decomposing at that time. So 28 minus 0, initially the oxygen was 0 because there was no oxygen. And then the time finally, we said it takes how many seconds? 15. So initially the time was 0. So 28 divided by 15, you grab your calculator. So 28 divided by 15, this will give us 1.87 centimeter cube per second, right? Right, so that's it to calculate the rate of reaction.
Oh my God!
Okay, then the graph below shows changes in the potential energy during the decomposition of hydrogen peroxide in experiment 1 and experiment 2. Let's take a look at that graph that they're talking about. So yes, here we are. And then this is the graph here showing experiment 1 and experiment 2. Now in 5.4, they say, write down the investigative question for this investigation right here. Now, we do know that when the graph is like this, the potential energy graph is like that, and then it has this broken lines here, it usually indicates the effect of a catalyst. How do we know that? Because we can see that the activation energy is being lowered. Remember, activation energy is from the energy of the reactants all the way to the activated complex, which is this peak value here. Now, this is the first activation energy for experiment 1. This is the activation energy for experiment 2. So as we can see here, the activation energy has been decreased. And then the only quantity that can affect the activation energy, we know it to be a catalyst. So that means in 5.4, remember, a powerful investigative question needs to say, what is, right? What is? Most of the cases we say, what is the relationship? So what is the relationship between a catalyst, and the rate of reaction? And the rate of reaction. Then you put a question mark because it's a question, right? What is the relationship between a catalyst and the rate of reaction? Or you can go, what is the effect? So what is the effect? So this would also be correct. What is the effect of a catalyst on the reaction rate? Of a catalyst on the reaction rate, or on the rate of reaction, right? So basically, you can put it this way here, or you can put it that way, right? So, but then your question needs to have what is. Don't say how or why, what is. And then you put a question mark at the end of the question. Okay, so that's it. Now, 5.5 says, is the reaction endothermic or exothermic, right? Now, in order to determine that, we have to know if the energy of the reactants is greater than the energy of the product. We know that our enthalpy change means that now it will be less than 0. If our enthalpy change is less than 0, then we know that type of reaction to be what? Exothermic, right? So that means the correct answer to 5.5 is exothermic reaction. And then give a reason for that. The reason, those are the reasons right there, right? So energy of the reactants greater than the energy of the product, right? Energy of reactants is greater than the energy of the product, right? So that's something that we can see right there. So the energy of the product is less than the energy of the reactant, or the energy of the reactant is greater than the energy of the product. Okay, so that's how you were supposed to answer that. And then 5.6 says, in which experiment 1 or 2 is the rate of reaction higher? Obviously, it has to be experiment number 2, since the activation energy has been lowered. And with the activation energy being lowered, it means that there are now more particles that will produce effective collisions. So experiment number 2. Experiment number 2.
I mean, I want them to know what Mojo doing to people. Oh, somebody, he needs some milk.
Okay, now 5.7, they say use the collision theory to fully explain the answer to question 5.6. To fully explain, right? So let's fully explain right now. So this is how you fully explain that. So you say a catalyst provides an alternative pathway of lower activation energy. When they mark there, they're looking for these keywords. Lower activation energy, right? And then now you are going to say point number 2. That means more particles will have sufficient energy to collide. Will have sufficient energy to collide. And then more effective collisions. More effective collisions per unit time. And then you can conclude, thus the rate of reaction increases. Thus the rate of reaction increases. And that's it, guys. That's how you explain this. So, okay, so make sure that you explain your collisions theory very carefully, and then the way they want them. So we have went through the notes on that one. You can check up the video on the notes that I went through on how to explain your collision theory for all the independent variables that you'll be investigating. So, okay, that's basically that, guys. So make sure that you come back to this video, watch it as many times as possible, and try to understand the approach that I took into answering all these questions here. But then with all that being said, you know what to do. Press that like button, press that subscribe button if you haven't subscribed yet. And also don't forget to share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.